Alright everybody, let's work out this next problem together. So what you had to do is you had to figure out how many grams of iron 3 oxide were needed to completely react with 0.50 moles of carbon monoxide. So again, let's pull out this really important information. So our starting point is going to be the 0.50 moles of carbon monoxide. And what you're looking for is grams of iron 3 oxide. Okay? So from here, the very first thing that we have to do is we need to convert from moles of carbon monoxide to moles of iron 3 oxide. And in order to do that, what are we going to use? I hope you guys said it. It's going to be your coefficients or your mole ratios from your balanced equation. So let's look at this. We need moles of carbon monoxide to cancel out. So I'm going to come up here to my balanced equation. I see I have a 3 out in front. So I'm going to put 3 moles of carbon monoxide on bottom. Next, I need to put moles of iron 3 oxide up on top. So I'm going to come up to my balanced equation. I see I have an understood 1 out in front of it. So I'm going to put 1 mole of iron 3 oxide up on top. My moles of carbon monoxide are going to cancel each other out. Guess what? We just converted from one compound to another compound. Now we are allowed to convert from moles of iron 3 oxide to grams of iron 3 oxide. Now in order to do that, we need to go forward and we need to calculate out our molar mass of iron 3 oxide. Now I went ahead and calculated it out. What you should have gotten was 159.7 grams per mole. Okay? That is your molar mass for iron 3 oxide. Now what we're going to do is we're going to plug that in to our balanced equation. So I need moles of iron 3 oxide to cancel out, so I'm going to put that 1 mole on bottom. Okay? And then that 159.7 grams is going to end up going up on top. Now again, just to reiterate, it's very important because this is a common mistake a lot of people make. When you're doing your molar mass, the numbers that you had calculated out when you're pulling your atomic mass from your periodic table goes with grams. And the moles will always, always, always be 1 mole. Okay? So once this happens, my moles of iron 3 oxide will end up canceling each other out. So now all I have to do is just do the math. When I end up doing the math, you should end up getting 26.62 grams of iron 3 oxide. Are we done yet? Nope, not yet. We have to look at our significant digits. So let's come up here and let's calculate out our significant digits. We have 1, 2. Now this time we only have 2 significant digits. The reason why is this first 0 is not significant, okay? So we're going to cross that. It's not significant. It's because it appears before the 5. It appears before a non-zero. It doesn't matter that the decimal is present. It comes before a non-zero. The second 0 is significant because of the decimal, and it comes after a non-zero. So we're going to take this, our 2 significant digits, come down to our answer. We have 1, 2. We're going to round that 6 based off the number behind it. So that's actually going to make it round upwards, and you should end up getting 27 grams of iron 3 oxide. How did everybody do? I hope you guys are doing pretty good so far. Now what we're going to do is we're going to take it a step further. We're going to see if you can reverse it. Can you go from grams to moles? So it's just doing everything that we've done already, but going the opposite direction. Once you do that, it's actually not going to be that bad. I promise you. It's going to be pretty easy.